How does JavaScript scope affect variable lifecycle and garbage collection? Imagine your JavaScript code as a busy city with neighborhoods where variables live. The scope of each variable decides which neighborhood it belongs to and how long it stays there. When you declare a variable, it gets a home in a specific scope. Global variables are like citywide landmarks. They stay around as long as the city exists. Variables inside functions are like residents who only stay during the event and leave when it ends. Variables declared with let or const inside blocks are like temporary visitors. They only stay within that specific area. When a function runs, it creates a new scope, and variables inside it are allocated memory at that moment. For var variables, this happens at the start of the function because of a process called hoisting. For let and const, the variables are in a sort of waiting zone called the temporal dead zone until they are declared. Once the function finishes, the variables that are no longer referenced become unreachable. The JavaScript engine then uses a process called garbage collection to clean up these variables, freeing memory for other uses. Closures add an interesting twist. If an inner function keeps a reference to variables from an outer function, those variables stay alive as long as the inner function exists. This means their lifecycle extends beyond the outer function's execution, which can sometimes cause memory to stay allocated longer than expected. In web development, keeping track of scope helps manage memory better. Avoid using too many global variables because they stick around for the entire page life. Use let and const inside blocks to limit variable lifespan and improve clarity. Understanding closures helps prevent unintentional memory leaks, where variables stay in memory longer than needed because of lingering references. So, the scope of a variable directly influences when it is created, how long it stays accessible, and when the garbage collector can safely remove it. This understanding helps you write more efficient code that uses memory wisely and runs smoothly.